Hello everyone. Today we are going to start lecture 2. Last lecture was all about introduction, so officially we are going to tackle the codes that we need to type in C programming from today. Alright, so this is the basic format of a very simple program in C. And please let me know if the slides don't go to the next one like previous session, but if it's okay, then let's move on. All right, so the first thing we should know is about this notation. It acts like parentheses. So we start from here and close it here. And whatever you type here, computer doesn't care about it. So why we use that? Because as we mentioned in the previous session, that we use programs not only to communicate with people, with computers, but also with people and users and other programmers. And that's the place that you can type and mention about the things that you just want to other users know about. For example, here we explain what is this program about. And you can do it throughout your program to explain even each statement, what is it about, and it makes your job easier to explain to other users what's happening there. The next thing you should know about is the library headers. So we need them so that C understands what we are talking about. For example, when you type printf, then C understands what is printf only if you include the standard input-output header. So this header is the most basic one that you can see in all the C program anyway. So you should include it so that we have our basic header inside our program. And in the previous session, I showed you there's a linker at the end so that it links your code with these libraries. And at the end, it makes it an executable program. All right, so this part. This is the main function. For function, we will talk about it in details in lecture number 6. Even we have a video for it. It's available, but let's wait because we need to cover more things before we reach functions. So this is the way we define function, and we will talk about it in details, why I use, for example, int, and why this is the name, and why this is empty inside it. In all the C programs, we should have this one anyway. This is the main function. It shows that your code is starting from here. So this one, curly brackets, these ones are block. And we will talk about block after the functions and why they are useful. But in the main function, we have a main block, as you can see. And at the end of it, we have return 0 all the time. So return 0 shows us that our program is done, and now we return it to the main function. We will talk about function in detail so that it will make sense later. But just remember, in all the C programs that we will type, we should start it from here as the function, and we will end it by this returning 0 as calling. And what is this one? Printf. Printf statement is used so that you can print out the results or maybe just a sentence for the user. So you see inside the double quotes, we said, hello there world. So the user will exactly see this sentence. /n here that we use, it just moves the sentence to the next one. And all of them have semicolon at the end. So each statement that you mentioned, we should finish it with a semicolon. We shouldn't forget it. So this one was header. And this one is starting our block in the main function, and return 0 at the end is the last thing that we should do in all programs in order to return the value. All right, so there are some escape sequences like /n that we talked about it, that it moves it to the next line because we want to organize our text. So this one is very useful, a /n. We have also a /t for just moving forward a tab, or using alert, because this one is important for getting the attention of the user sometimes, so that we need him to type something. So this one can be used too. As you can see, a slash, and after that, a character means something for C program. So in order to type a slash itself, we need to use double slashes like that. And we have a slash before double quote because inside the printf, you see, we already have double quote. So that if you want to show the user double quote as a text, so in that scenario, you need a slash double quote like this. All right, the next example. This program adds two integer numbers. So as you can see from the beginning, you should include this library, this header. Then this is the main function and return 0 at the end. So you see this is repeating itself all the time. Again, we use this notation, so computer doesn't care what you are typing here. This is just for communicating with other users and programmers. Now, this is the way that you define your variables. This is the name of the variable, and this is the variable type. Int means integer. So for integer numbers, we use int. And later we talk about the other types that we can use too. So type of the variable, the name of the variable. You can even finish it by semicolon here just to define it. Usually I prefer it because later for modifying the program, it would be much easier. But anyway, if you are sure that you just want to assign it 35 at the beginning, so you can even assign this number to this one. We should pay attention to equality sign here. What does it mean? Because in mathematics, when you have such a case, it means equality. It means that left side is equal to the right side and vice versa. But for programming languages, this is usually the case that we are assigning this value to this variable. You see? So this is a variable that we define, and this is the number that we are assigning to it. So next time when we ask, for example, what's the value of first number? Now we know this is 35. So this is the way we are assigning number, and through the program, maybe we will change the number for first number again and again. But in this simple example, we know that for sure this is 35 from the beginning. And for summation, we define a new variable named sum. I usually prefer for each one of these variables to define it separately, like int second number semicolon, int sum semicolon. But sometimes in order to type them fast, you can use comma like this, and at the end finish it by using the semicolon because you want to define all of them as integer, right? So you can do it as well. After that, we want to add these two integer numbers together. So sum is equal to the addition of these two variables. Then we can print out the result. Pay attention to the way that we are showing printf statement. So you can see here we have %d. What does it mean? Again, we have another one here, another one here. The other one are just text, English, we understand them. But this part, it's related to printf statement. Whenever you see %d, it means that we want to report something from our variables. So after this double quotation, you see quotation ends here. After these two double quotation, we have comma. Then we can mention about those percentages one by one. So first number corresponds to this percentage. Again, second number to this one. And why this is d? Because it corresponds to integer. For each one of the variable types, we will have different characters representing them. So for integer, they use d. So that's the way when you print out the result, it says first number is 35, second number is 21, and then the summation will be the summation of these two, which is 56. So these ones, please also later check them out, that what we mean by each one of these components. All right, so next one. Again, you see we include the header, standard input output header. This is our main function. Again, we finish everything by return 0 at the end. We shouldn't forget it. And we are defining two variables now. And we define it as float, not integer. What is float? What does it mean in C programming? In mathematics, we have integer numbers, and also we have rational numbers. Rational numbers can contain also decimal points, like this one. You see 3 point something. It contains some decimal point, and even this one could be defined as float number too, as a rational number as well, because integer numbers are subset of rational numbers. So whatever you have as integer numbers are inside rational numbers as well, right? They are subset of that set. So here we define them as float. Usually I prefer in my program to define everything as float because integer are already included in that. But if the question specifically asks you to define it in terms of integer, so there's no other choice with that. So the type is float for these two variable names. All right, so radius, we assign it to be equal to 2. Circumference is equal to this formula, 2 times pi multiply radius. And again, be careful that we are finishing with semicolon each one of our statements. And at the end, we are going to print out the result. And as you can see, the difference is that we use %f instead of %d because this is the float type of variable. So in the previous one, we use %d. In the current example, you can see %f. And what variable this one corresponds to after this quotation, you can see we have comma and we name that exactly which variable we are talking about. So again, read these components later to check them what they mean. Whenever we show results, and this is a sample run, it means that what it looks like when you run the program. Okay, here, let's see what it does. It's just mentioning about the usage of this /n, that if you want to have the second line starting from here, then you just separate them by a /n. It's obvious, and we explain it at the beginning. All right, so we mentioned about different data types, integer, float. Also, we have characters, and we show them by char. So we show characters by using char, and for each one of the elements, we should be careful that we put them inside single quotes, not double quotes. Single quote, but for numbers, as you remember, we don't even need these quotes anyway. You see, for example, these are the numbers, and we can show them like this. And integer and float, both of them can have negative value anyways, right? And sometimes you see in programs, they mention about double. Double actually reserves more memory, and you can define longer decimal points. Usually we don't use it in our programs in this course. So just for you to know, if whenever you see double, it's just floats, but it contains more decimal points. This example is very important in order to understand why double %d, %c, or these things are important and how it affects the final result and the decimal point that you define before f. So take a look at this one. There are sequence of printfs. This one prints out 56 because this is an integer and this is also an integer, so directly 56. This one, you can see you can have your calculation also here inside this part of the printf statement. So inside printf statement, it is possible also to have your calculation. I usually don't suggest it because for modification, sometimes it complexes things, but anyway, it's up to you. So it will just print out the result, not exactly these two, but the result of them. The same situation for multiplication. So for multiplication, we should be careful. We should use asterisk sign like this. And for character now, we define a new letter C. So %c corresponds to characters. So now we know %d, %c, and %f. %d for integer numbers, %c for characters, %f for float numbers. And for characters, be careful that we should put them inside the single quotes like this. All right, so the rest you know until this part. This part is also very important. You see, when you type %2.1f, what does it mean? It means that I'm interested on 2 digits on the left side of decimal points and 1 digit from the right side. Whenever you have only 1 digit on the left side, it will show only that 1 digit anyway. So that one doesn't use that much. But dot a number, this one used a lot. Then you exactly specify how many decimal points you want. So you can even say 0.1 and it will show you, or just 0.1, because sometimes 0 makes this part disappear, so we don't want that. So for example, for this one, 2.2, it's written 1. So you see 2.2, only 1 digit on the right side of the decimal point. But before, when you just use F, percentage F, then 2.2 has 6 digits on the right side by default. So if you don't define it, you will get such a number printout on your monitor. So for example, here you have 3 after the decimal point, you have 3 digits on the right side of your decimal points. Okay, now it's time to learn about scanf, because not all the time you are defining all the constants or variables yourself. Sometimes you want user to give you information. So in that scenario, again, you use this header. I keep repeating it, not for the next sessions, but we should remember this one we need as the library, as the header, to be included in our program all the time. For all the programs you will type from the first session to the last one. All right, so the main function includes these 4 float variables, and then we print out, please type in a number. So whenever you want to ask user something, you use printf. You simply ask the user to enter a number, and when you want to get number from the user, you want to assign it to a variable you already defined, number 1, number 2, number 3, and product. So here you want to assign it to number 1. Such assignments needs such a notation, and sign. So you use and sign before number 1 to assign this number, which you get from the user. And you also specify this number should be float number. You don't get, for example, characters from the user. So percentage F was used here because you know you need a float number to get from the user. So that's how we define scanf. And you see all the time semicolon at the end of each statement. Again, we ask the user to give me the second number, again, percentage F, number 2. Then you multiply these 2 numbers together and you get the product. So this number 3 was totally redundant. We didn't even need to define it. So we should avoid such redundancy inside our programs if we don't need it. So at the end, when you want to report the result, again, we need printf statement. You have 3 F percentages, and number 1 corresponds to this, number 2 to this one, and product to the last one. So it needs some practice in order to get used to it. So each one of these examples, please try to retype them to get used to all of the statements. All right, so next example. Here we define 3 integers, and we ask the user to give me the first integer. Then you see here we define percentage D instead of percentage F because I know that this variable has integer type. And we just save the summation inside this sum variable. Sometimes the students forget to define, for example, this one. Not only define the variables that you want to get from the user. This one should be defined from the beginning. That's what's the summation type. So integer sum. And at the end, we print it out. So this one should be easy for you now. All right, there's a way that you can define a constant before the main function like this. This one is not a header. You see, this one is different. We define a constant before the main function. You could also define it inside the main function like before. But sometimes it can be useful, especially after we will learn about functions. We will learn about global variables and such things. So these things would be worthy for us. Because no matter what happens inside the function, always pi is equal to this number. And as you know, pi is an irrational number. It means that the decimal point doesn't stop here, it goes to infinity. But this is a kind of approximation, so that's why we define it, for example, like this. So inside the main function, you define radius and circumference as float types. You see here we define a constant directly without asking the user. We could do the same for pi, right? But we just introduced you another version of just assigning constant before even starting our function. And okay, here we calculate circumference, and the rest you already saw and you are familiar with that. So in any programming languages, we should know about the signs, the notations that they use in their typing. For example, asterisk is used for multiplication. If you insert x, so it doesn't understand that you mean multiplication. Or backslash like this for division. And please pay attention, whenever you divide 7 by 5, if you define the result as float number, it will exactly show you with decimal points what's the result. But when you define the whole thing as an integer, then in that case, you will receive 1 as the final answer. So this is 1 point something, so it doesn't consider the decimal point. Even if this is 1.9, it considers it 1. So it doesn't round it up. So it's usually the left side of the decimal point. So here we have modes. For modes, we show it by percentage sign. So 7 mod 5. It means that what's the remainder of this division? So it shows you the remainder of that division. And if, for example, the number that you have here is smaller than the right one, exactly the number on the left side will appear here. For example, if this is 1, 2, 3, 4, again, you will have here 1, 2, 3, 4 as the remainder of that division. Sometimes it happens, so we should know about that. All right, so sometimes order matters, and we should know exactly, for example, should we calculate the multiplication first? Shall we calculate the summation first? These things have order, and we should know about the orders. Like, for example, here, it means that A plus B, these ones we will have the summation, but this part will be calculated first. C is being divided by 3. If you want to divide the whole summation here by 3, you need to use parentheses like this. Okay, so these things are important. So there are some signs that we already talked about it. So plus and minus exactly the same. Asterisk sign for multiplication. Backslash for division, and mod, as you can see, in percentage format. And here's the order, which is important. So whenever you want your calculation to happen first, you put them inside parentheses. So A plus B plus C inside parentheses. So first you get the summation, then you divide it by something. Then multiplication, then division, then remainder. You see remainder has a higher order comparing to summation and subtraction, because remainder is obtained by using division anyway. So this order matters before summation and subtraction. Here are some logical operands and the relation between two variables. Like here, whenever you want to check whether two variables are equal or not, you use double equality. Why not just one? Because when you use x is equal to y, it means that you assign the value of y inside x. But this one with double equation, it means that now you have checked that whether x and y are equal or not. So this one shows equality, and this one shows not equal. And here, greater than, less than, greater than or equal to y. And be careful that we should use greater than or less than before equality. If you put, for example, equality here, then greater than or less than, C doesn't understand. So you see, in mathematics, we show it like this or like this, but in C program, it's a bit different. we have a library named mathematical library functions, and we call it math. So whenever you want to activate functions like getting the square root of something or the power, then we need such library. So math header, we should include it as well. Otherwise, if you don't include it and you type them inside your program, C doesn't necessarily understand it. So we include that one because of such functions, and easily we can calculate them. Like here, for example, it's 7.6 power 3. And here we get the square root of this one. And as we said, we can include them even inside the printf to calculate them directly without introducing new variables. And here, for example, we find the absolute value of a float variable. So we should know about these functions that when using math library, we can easily activate them. Like square root, power. Here we have the e power x. So Neperian number is powered by x. So we show it by exp x. Logarithm x. This one is showing with base e. And for 10, we should use logarithm 10x. This is different from mathematics. In mathematics, when you write logarithm x, it means that base is 10. But here in C programming, whenever you use logarithm x, it means that ln x. So we should be careful about that. When you want to use a specific base, even for 10, you should mention it like this. And these two also, as we mentioned, calculates the absolute value of x. Okay, so it was all about the second lecture. I hope it was useful for you. So if you have any question, please ask me. Otherwise, we can have a 10 minutes break. You can ask me question if you have about worksheet number 1. We usually deal with the previous worksheet, not the current one in our lectures. But anyway, since we don't have from the previous ones, you can take a look. If you have any questions, you can ask me from 10 minutes later.